Hello students, welcome to GATE Electronics Guruji classes. In the last video we discussed 6 properties of even signals and odd signals. And in this video we are going to discuss the rest of the properties of even signals and odd signals. The seventh property says that even signal multiplied by an odd signal results in an odd signal. Let me take an example of this case to explain this. Suppose we have a signal xt such that xt is equal to t square into t cube, and t square into t cube is nothing but equal to t to the power 5. We see that t square is an even signal because the power of t is 2, which is an even number. So t square is an even signal. You see that t cube is an odd signal because the power of t is 3, which is an odd number. So t cube is an odd signal. And t to the power 5 is also an odd signal because the power of t is 5, which is an odd number. So t to the power 5 is an odd signal. So you see that if you multiply an even signal with an odd signal, the resultant signal is itself an odd signal. Now come to the eighth property, which says that 1 divided by even signal results in an even signal. Let me take an example of this case. Suppose I have a signal xt such that xt is equal to 1 divided by t square. You see that t square is an even signal because the power of t is 2, which is an even number. So t square is an even signal. So t square is an even signal. And let us find out x of minus t. X of minus t is equal to 1 divided by minus of t whole square. That is 1 divided by t square, because minus t whole square is equal to t square. And 1 by t square is nothing but xt. So you observe that x of minus t is equal to xt. So xt is an even signal. So you get that xt is an even signal. So finally you can conclude that 1 divided by even signal is an even signal. Now let us come to the ninth property that says that 1 divided by odd signal is an odd signal. Let me take an example of this case, though these things are pretty obvious. I guess you can understand. xt is equal to 1 divided by t cube. You see that t cube is an odd signal because the power of t is 3, which is an odd number. Now let us find out x of minus t. So let us replace t by minus t. So minus t whole cube. You can take this minus sign outside because the power is 3, which is an odd number. You will have minus of 1 by t cube, which is nothing but minus of xt. So as x of minus t is equal to minus of xt, so clearly xt is an odd signal. So you have 1 divided by odd signal is an odd signal. Come to the next property that says that ddt of even signal equal to odd signal. That means if you differentiate an even signal with respect to time, you will get an odd signal. Let me take an example of this case. Suppose xt is equal to t to the power 4. Clearly you see that t to the power 4 is an even signal because the power of t is 4, which is an even number. If you differentiate t with respect to time, dxt dt will come out to be equal to 4t cube. 4t cube is an odd signal. Why? Because the power of t is 3, which is odd. And this xt was even signal because I already showed that xt equal to t to the power 4 is an even signal. So what you have is, if you differentiate an even signal with respect to time, you will get an odd signal. Clear? Similarly, property 11 says that if you differentiate an odd signal with respect to time, you will get an even signal. Let me take an example. Suppose we have a signal xt equal to t cube. Clearly this is an odd signal because the power of t is 3, which is an odd number. Let us differentiate xt with respect to time. You will have 3 times of t square. And t square is an even signal because the power of t is 2, which is an even number. So if you differentiate an odd signal, here xt was an odd signal. If you differentiate an odd signal with respect to time, you will get an even signal. That's what the property 11 says. Okay. All right. Now let us come to the rest of the two properties. The rest of the two properties says that if you integrate an even signal with respect to time, you will get an odd signal plus a constant, which is called as the arbitrary constant, or also called as the concept of integration. Let me take an example. Let us take xt is equal to t square. If you integrate t square with respect to time, you will get t cube by 3 plus c. See, t square is an even signal because the power of t is 2, which is an even number. T cube is an odd signal because the power of t is 3, which is an odd number, right? So clearly, if you integrate an even signal, you will get an odd signal plus the constant. Similarly, if you integrate an odd signal with respect to time, you will get an even signal plus a constant c. So let me take an example of this case. Suppose you have the signal xt equal to t cube. If you integrate t cube with respect to time, you will have t to the power 4 divided by 4 plus c, where c is the constant of integration. T cube is an odd signal because the power of t is 3, which is an odd number. T to the power 4 is an even signal because the power of t is 4, which is an even number. So clearly, if you integrate an odd signal with respect to time, you will get an even signal plus the constant of integration, right? And I want to say one more thing here that I forgot to tell you. I showed you that if you differentiate an even signal with respect to time, you will get an odd signal, but don't think that if you differentiate a constant value or a DC value with respect to time, that would be an odd signal. No, that won't be an odd signal. See, so we have a DC value xt is equal to 10. If you differentiate this with respect to time, you will have dxt dt equal to 0, because if you differentiate a constant with respect to time, you will get 0. So clearly, if you differentiate an DC value, you won't get an odd signal. You will get 0. I hope the idea is clear up to this part. So if you have any doubt up to this part, please let me know in the comment section. And again, I am requesting, if you think that these videos are being beneficial for you, then please subscribe to my channel. Ask me any doubt that you have, because keep in mind that it's your likes, your comments and your subscriptions that motivate me to make more and more videos for you. Thank you.